Okay, good evening all. Everyone can hear me? Online students? Online students, is my voice is loud and clear? Done. So let's start the session. So in today's class, we are going to discuss the next library called as Matplotlib, right? So where it is a plotting library. Okay, Matplotlib means mathematical plotting library, right? So this is a mathematical plotting library where in this particular library, we are going to make different types of plots. The plots related to histogram, the plots which are with respect to box plot, like this example. So like this, we are going to do multiple plots like bar plot, okay, and with respect to pie chart, pie plot, time series plot, whatever we have discussed in the statistics for different types of variables like continuous variables and discrete variables. For continuous variables, we are going to apply the histogram and box plot. For discrete variables, we are going to apply bar chart and pie plot. For time series variable, we are going to apply the line plot, time series plot, right? Theoretically, we have seen in the descriptive statistics. Let us see now the practically within the Matplotlib library. So this is the basic library within the Python. This is the basic library, right? For the visualization. So they are having some of the advantages of Matplotlib are very generally easy to get started. Means for if you want to start anything, this is the first one, best one, easy one. And it supports the custom labels. Now, what is meant by labels? Labels means whatever you are going to write on the x-axis, the name on the x-axis. For example, you are considering the age of a person. Assume that age of a person. So you can write the age, the name, whatever the name you want on the x-axis. What is the name you want on the y-axis? That is count by frequency or something. What you want to write on the y-axis. Okay. For example, you are making some kind of experience versus salary. Okay, this is experience. This is salary. And you want to make a plot between the experience versus salary. So as the person experience increases, how the salary increases. This is the plot. So here the word of experience word is there, right? That word you want to write on the x-axis, the word salary you want to write on the y-axis. These words are called as labels. These are called as labels where you can write on the x and y axis. And the text means within the line plot, you can write the name. What is the name you want to allocate to this particular line? So it is going to support the custom. Custom means user defined. We can write as per our own. It is not fixed every time. We can write as per our own. High quality output you are going to get and very customizable in general. So these are the advantages of Matplotlib. So let us get into one by one. So here I'm going to take the NumPy, pandas, and the third one is import matplotlib.pyplot as PLT. Now, till now we have worked on the NumPy and pandas. These two everyone knows. Now the third library which we are going to work is called as matplotlib. So instead of importing matplotlib, we have to import the matplotlib.pyplot. .pyplot. What is meant by .pyplot means .python plot. So this matplotlib library is also works in the respect to in the they have created this one in the other programming languages also. Like one of them is MATLAB. So in the MATLAB also we are having with respect to matplotlib. So here we are going to import the matplotlib.pyplot. .pyplot means Python plot. So now whatever the matplotlib we are going to work within the pyplots which are available as the Python plots we are going to work. So I'm going to import the directly matplotlib.pyplot as PLT, right? So now this is the matplotlib.pyplot as PLT. And second, we are having percentage matplotlib inline. We are having matplotlib inline. Now what is meant by this means all of them, all whatever the plots you are going to make, every plot should be inside this one inline. Inline means it should not cross, including your labels. It should not cross this line. That is the meaning of percentage inline. Now, as per the latest versions, we no need to write this one. Earlier previous versions we have to write. So if you are following any some of the materials, in that materials, if they have taken that percentage matplotlib dot inline, still it is available, means they are working with the previous version. That is the meaning. So for the latest version, you don't need to write this one. Automatically, it is inline only. Everything is right. Now, next one is DF. I'm going to create a data frame. So data frame between the study hours versus grade. So this is the completely data frame which we have created. So we are having some study hours, and based on that, what are the grades the students are getting. So if they study for 10 hours, the grade is 50, 11.5, 50. Something I'm having like this, assume. Okay, this is the number of study hours and this is the grade. Now this grade is out of 100. This grade is out of 100. Few people has got 3 marks and few people has got 97, 47, 26, something. And we can see here, two of them are 119 and 165. So what is meant by this? Let us understand one by one, right? Now here, what I'm going to do is first, I'm going to do the df.info. df.info means it is going to give the information where total number of records are 15 records and 2 columns are there. So the shape of this data frame is 15, 2. This is the shape. Okay. And next, I'm having with respect to the column names, study hours and grade. These are the column names. Data types are, one is float and one is int. Okay. So this is the total data set. Now let's start with the analyzing the variables. Now here, within this analysis, we are having the different types of analysis. One is called as univariate analysis. Univariate analysis means analyzing single variable at a time. It is called as univariate. Bivariate analysis means considering 2 variables at a time. Means that particular analysis you have to do means you have to take 2 columns. You can't analyze on a single column. 2 columns are required to do that one. For example, one of them is correlation. If you want to identify the correlation, you require the first variable and second variable. Only using the first variable, you can calculate only the variance you can calculate. But if you want to calculate the correlation or covariance, minimum 2 variables are required. Without 2 variables, you can't apply the correlation or covariance. Okay. So that is with respect to bivariate analysis. Bivariate analysis means the analysis we can do by considering 2 columns, 2 variables, 2 futures. By analyzing 2 futures, then it is called as bivariate. If you are analyzing using a single future, means only 1 column data if you take and if you analyze, means then it is called as univariate. If you are taking 3 columns, multiple columns, more than 2, if you are considering more than 2, then it is called as multivariate analysis. More than 2 means multivariate, right? Now, let us see the first one called as histogram. The first one we are starting with the histogram. Now, histograms comes under univariate or bivariate? Univariate or bivariate? So histogram, where we are having for a single column, we are considering a single column, whether it is a grade or whether it is a study hours, whatever it is, one continuous variable we are going to consider. Within this continuous variable, whatever the values are there, these values we are going to make a plot like this. This is the value, this is the grade. For example, you are applying on the grade. Let us assume you are taking the grade column. For the grade column, whatever the marks, grade means nothing but marks. Okay. Here, whatever the grade is there, grade is nothing but marks. Now you are considering the marks column on this, and automatically you are having with respect to this one is called as count. Means here you are considering 1 variable or you are taking 2 variables, study hours and grade, both you are considering. How many variables you have considered here? Only 1 variable, that is grade column only you have considered. You have not considered the study hours. For example, here study hours 0 is there. Is there any problem for you? Here 2000 is there. Any problem for you? Because you are not focusing on this. You are analyzing this one separately. Irrespective of that variable, you are analyzing this variable. Singly, you are analyzing the grade column. Then it comes under univariate analysis. So now whatever the histogram is there, I am going to consider the histogram where for writing the histogram, tlt.hist. You have to take the function called as TLT. TLT means nothing but matplotlib dot hist. Within that, histogram is the function. Histogram means hist. Now hist, inside this, you have to give the variable. For which variable you want to apply the histogram, you have to give. Which variable you have to apply? Continuous variable. You have to give the input as continuous variable. You can't apply the histogram on the discrete variable. You have to give the continuous variable.
Now I'm giving the plt.hist df of grade. Df of grade means it is going to do. Let us see this one. I'm going to make this one hash, 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 and hash. This I'm keeping as the common. Okay. I'm now in this particular cell, how many lines are there? Only one line. That is plt.hist df of grade. Let us execute this one. So now once you execute this one, you are going to get a histogram like this. For this data set, this is the histogram where you are having the multiple bins are there. Each bin starting is from 3 to 19.2 is the one bin. From 19.2, 35.4 another bin. 35.4 to 51.6 is another bin. 51.6 to 67.8 another bin. How to calculate the bin size? How to calculate the bin size? This is the bin size. 3 to 19.2 is the bin size. How to calculate this? Maximum minus minimum divided by number of bins. So it is going to check for this data, what is the maximum value? It has got the maximum value as 165. What is the minimum value for this column? 3 is the minimum column. By default, it is going to take the number of bins is equal to 10, which is nothing but 162 divided by 10, 16.2. So that is the reason first bin is from 3 to 19.2. Starting from 3, minimum value. It is starting from the minimum value. And the first bin, the bin size is 16.2. Sir, what is that meant by this? Let us see here clearly. Okay. This is starting is 3. 3 to 19.2. This is the distance. Total distance is 16.2 is the distance. What is the height? Height means total number of count. How many of them are there between 3 to 19.2? That is the height. Height is given by the number of variables, number of count. Based on the count, you are going to get the height. Whereas this width, this is the bin width. The width, how you are going to get the bin width means the bin width you are going to get based on the maximum minus minimum divided by total number of bins. By default, it is going to take the number of bins is equal to 10. So this is the first bin. This is the first bin. This is second bin. This is third bin, fourth bin, fifth one, sixth one, seventh one, eighth one, ninth, 10th. So like this, we are having total 10 bins. Total 10 bins are available. Is that clear? Now, for example, if you are considering here, let us go with the number of bins. Okay. Where I'm going to write the bins is equal to 5. I have written 5. Now, what would be the bin size? 165 minus 3 divided by 5, which is nothing but 162 divided by 5. Each bin width, the bin width is going to be 30, 15, 32.4. So the first one is going to start from 3, ends with 35.4. Means plus 32.4 you have to add. For this, you have to add 32.4. What would be the next one? 67.6. So you are going to get like this. Let us see. 3 to 35.4, 35.4 to 67.8. Okay. You have to add additional 32.4 for this. Whatever you have got, again, you have to add 32.4. Every bin size is equal to 32.4. And total, you are going to get 5 bins. This is your first bin, second bin, third bin, fourth bin, and fifth bin. Total 5 bins are there. 1, 2, 3, 4, 5. Now, sir, total 5 bins I have to select, total 6 bins I have to select. Which one? What is the total number of bins I have to select means you don't need to select anything. Just to keep as the default. Whatever the default it is having, keep as it is 10. Now, what is the use of histogram? Okay, I'm keeping as 10. Next, what is the use? Histogram tells us 2 things. One, whether the data is a right skewed or left skewed. Now, this one, if you observe this one, this is a right skewed or left skewed? Right skewed. Completely, it is right skewed. You can clearly observe that one. And right side, the values are very low. And whereas the left side, the maximum height is there. It is a right skewed. Okay, where you are having the right skew. This is option. First one you are going to observe from the histogram. What is the advantage of the histogram is we can observe whether it is a skewed distribution or normal distribution. That is the first one. Second advantage is we can analyze which particular bin means which particular data is having more number of values. Means from this I can understand that many of them are from here to here. Many of them are from here to here. Right? Since this bin is maximum height is there. So I can understand from this, many of them are from here to here. Okay. Now, that is the use of histogram. Histogram tells us one is whether it is a skewed data or normal data, and it tells that within the given bin, what is the how many number of people are there. That is the advantage, right? Now, next, if you observe, this is the diagram, and if you right click on this is the plot, and right click on this, click on the save as, and save on the desktop. Okay, I'm saving on the desktop. Now I'm just opening this one. Now if you open this one, there is a histogram you have saved on the desktop and you are opening. Now here, this is a histogram of what variable? Grade variable you have taken for the grade. Where is that? How you can identify that one? For example, you have saved like this, total 20 plots you have saved. Within the 20 plots, which one is related to which variable? How you can identify? There is no name, nothing, right? So what I'm going to do, I'm going to add the name for that. That is the X label. X label means adding the name. So now I'm going to add the name. Now you can see here, it is adding the name called as grades. Okay, this is for the grades variable. What are the name you have written here? It is going to add. If you write here, X label is equal to marks, it will add the marks, the word called as marks. What are the name you are writing? That is called as customization. Customization means we can write our own name. Whatever the name we are interested, we can write as per our choice. They are called as custom labels. Okay, if you're not having that option, automatically Python only selecting means then it is not called as custom labels. Custom labels means we can write, right? So this is with respect to the grades or marks, and on y-axis is nothing but their count. Count is on their y-axis. So the grade, the marks are from 0 to 19.2, 19.2 to 39 point something. So like this, whatever the marks we are having, the marks values are on the x-axis, and their current count or frequency is on the y-axis. X-axis consists of variable name, that distribution, and this is called as frequency distribution. We have discussed, right? Continuous frequency distribution. What is meant by continuous frequency distribution? You are applying a frequency distribution on a continuous variable. What is meant by frequency distribution? The distribution of the data represented on the x-axis along with their frequency on the y-axis. Then it is called as frequency distribution, right? Now, title. Title means I want to add the title for this one. Title means you can see here on the top. Okay, on the top you can see the title. That is histogram of the grade. Title. I have created the title. This is called as title. This is called as Y label, and this is called as X label. These three of them, right? And next, if you observe here, there is something called as txt 0.51 histogram of dead fund, something is there, right? If you observe this one, if you remove these three, okay, earlier, if you remove this one, it is showing the count by frequency, means what is our last line, it is showing there in the last line. If you write a hash here, it is going to show the marks. If you hash this one, what are the last line executed, that last line it is considering here. So if you write only the histogram, it is showing the all these things. So now just I don't want all these things to be printed, nothing to be printed. Then what I'm going to use? Now if I write like this, something is getting printed here. Something is getting printed here. This one also I don't want to print. Means what I have to use? plt.show, then it will only show the plot directly. plt.show means show the plot, no need of remaining things. You no need to show me what is the size of the letters you have considered, or what is that thickness you have considered. Nothing you don't need to show me. Just show me the plot. Directly get into the plot. So directly it will show the plot for you. Is that clear? The meaning of each and every line. First line indicates the histogram of a variable. X label, Y label, title, and plt.show means it is going to show only the plot. And this I have applied on a single column called as grade. So it comes under univariate. In this particular function, I have given only a single column. Okay, if I want to check for the study hours, I have to replace this one to the study hours. Okay, if I modify this one to the study hours, I am going to get the for study hours the histogram separately. Each of them, for each variable, we are going to calculate the histogram separately. Right? For each of them, we are going to calculate the histogram separately. So this comes under univariate analysis. This comes under univariate analysis. Histograms comes under univariate analysis because you are analyzing only a single feature at a time. Right? Next comes to the box plot. Next one is box plot. Now I'm going to take the plt.boxplot. plt.hist gives the histogram, plt.boxplot gives you the box plot. I'm going to take the plt.boxplot where I'm going to give the input as df of grade column. And so it is going to apply the box plot and plt.title. Title means what? For every plot, whatever on the top we are going to get, this is called as title. So for this plot, whatever the plot it is going to create, for that plot on the top, I want to create the name called as box plot of the grade column, grade future. plt.show. So plt.show means, so it is going to show the this one, box plot. And in the box plot, if you observe here, there is a outlier. This is an outlier. This particular thing is an outlier for the given data. So we are having the outliers. Now, what is the use of box plot? What is the use of histogram? We have seen. Now, what is the use of box plot? Box plot is used to identify the whether the given data has outliers or not. That is the only use of box plot. Whenever you want to check whether the given data has outliers or not, miss, immediately you have to use the box plot. Now here, box plot is one dot is there, but what is the number? What is that number? We don't know. That number we don't know. Which record and which value? What is that value? We don't know that value. Just we know whether they are outliers or not. In our data set, outliers are present. Yes or no. That's it. For that one only, it will give the answer. If dots are available, miss, outliers are available. If dots are not there, miss, outliers are not available. Simple. Right? Now, sir, for example, if I want to extract that data, whichever the outliers data is there, that data I want to extract. Now tell me whether the outliers are there on the right side or this left side or right side, the outliers on the upper side. Now, how to calculate this maximum value? What is this maximum value? Q3 plus 1.5 into IQR. So you are going to calculate first the Q3 value. After calculating the Q3 value, you have to calculate Q1 value and you have to calculate IQR value. After calculating IQR value, then what do you have to do? You have to calculate the Q3 plus 1.5 into IQR. Now, any value greater than that is considered as an outlier. So first I'm calculating the Q3. How to calculate the Q3? Q3 is equal to df of that particular variable, whatever the variable you want, grade dot quantile of 0.75. If you ask this one, you are going to get the Q3 value. Okay, where is Q3? Okay, this is Q3 value. Similarly, you are going to calculate the Q1 value. Q1 value is equal to df of grade, which is of 0.25. This is the Q1 value. Once you calculated the Q3 and Q1, you are going to calculate IQR. IQR is equal to Q3, whatever the Q3 minus Q1, whatever the Q1 you are having, Q1. Once you calculated the IQR, next you are going to calculate the upper limit. What is the upper limit? Upper underscore limit is equal to Q, that is Q3 plus, you are calculating the Q3, whatever the Q3 plus 1.5 into IQR, 1.5 into IQR. Once you calculate this one, you are going to get the upper limit value. Now, what is the upper limit value, miss? Upper limit is 128.25. Anything more than 128.25 is considered as an outlier. So how to extract that particular data? Now, df of, already I have told you, just a filtering method. In the pandas filtering method, what is the filtering method? Filtering method means nothing but df of grade for the grade column, wherever the value is greater than upper limit. You have to write upper limit. Now, automatically, you are going to get this is the data. Outlier data is this one. This is considered as an outlier. So in your data set, whichever the value is greater than 128.5 is considered as an outlier. Which data is having more than 128.5? This is the one. So that is considered as an outlier. In this way, we are going to extract the data. For data extraction, we are going to use the pandas. We are going to use the pandas and we are going to extract the data, which is outliers. Similarly, if you are having left side, lower side, then Q1 minus 1.5 into IQR. Whether it is 1 or whether it is 10 or whether it is 20. For example, I'm having like this lower limit. I'm going to write the lower limit also. Lower limit is equal to Q1 minus 1.5. Q1 minus 1.5 into IQR. Right? Now here, what I'm going to write? Condition like this. Any value greater than this one, or what is the second one? Or same thing, any value less than this one. Either this one or this one also is considered as an outlier. Any value less than lower limit. Less than lower limit is considered as an outlier. So this is for all. So you are going to write like this. Every time this is the fixed code. To check the outliers, this is every time fixed. It is not going to change. Only changes, you have to change the column name. For different variables, you have to name the column name. Right? So here I have written very clearly step by step. That is calculate the Q3, calculate the Q1, calculate everything. I have written the very step by step. If you're not able to write these many steps, means just you're going to copy this one. Wherever the Q3 is there, copy the Q3, this one. And wherever the Q1 is there, replace this one to this one. So this is Q3 and this is Q1, right? No, you no need to write to the additionally these two also. Now, wherever the Q3 is there, copy this one here. And IQR, copy this entire things, copy, paste. And similarly, this one. Now you are not going to create the temporary variables. Nothing is required. Directly, only 3 lines of code is required. These 3 lines also you want to bring into one line, miss. Just this upper limit also you replace with that. Then you will get in only one line. Right? That is your choice. If you want to get confused of yourself, miss, you can write like this. If you want to get clarity one by one, separately, miss, calculate as per your choice. If you want to create the multiple variables also, you can create the multiple variables. No one is going to say that is wrong, this is wrong. Okay. Clearly, I have written the Q3 separately. I'm calculating. Q1, I'm calculating. After that, IQR, I will calculate. After that, upper limit and lower limit, I will calculate. And based on that, whichever the data is outliers, I'm going to extract the data. Right? So to extract the outliers data, we are going to use the pandas. But to check whether outliers are there, that we are going to use in the box plot. First we'll check whether outliers are there. If outliers are there, means then we'll write this code. If outliers are not there, then what is the use of writing this code? I assume that data is not having outliers. Why you have to write this code? You don't need to extract the data of outliers. There is no outliers only, then why to extract? Right? So now, in this way, we are going to check the outliers. If there is outliers, means we are going to extract the outliers. Now, after extracting the outliers, what we are going to do with the outliers is data cleaning process. Checking is one, extracting the data one. What we are going to do with these outliers is another one. 3 are different steps. 3 of them are different. One is identify. If the interview, they'll ask you how to identify outliers. If they ask the question, how to identify outliers, means by using the box plot. They will ask immediately how the box plot works. Box plot works based on the concept called as 5-number summary by using the minimum Q1, Q2, Q3, minimum value Q1, Q2, Q3, and maximum value. Any value greater than Q3 plus 1.5 into IQR is considered as an outlier. Any value left side Q1 minus 1.5 into IQR is called as outliers. Next. Okay. Then can you identify what are the values of outliers are there in the box plot? Can you identify the values? No, that is not possible. In the box plot, we can't see the values. Only we can see whether they are present or not. That is only possible in the box plot. Okay. Then how you are going to extract the outliers in your data set? By writing the condition. By using the pandas, we are going to write the condition and we are going to check which are the values satisfies this. Right? Next. Then how you are going to treat the outliers? That is next different question. How to treat the outliers? How to treat the outliers means you should not say, sir, box plot. Box plot is for identifying. For treating the outliers, box plot is not the solution. Right? So for how to treat the outliers means, for treating the outliers, we are having 3R technique. One is called as remove, means remove the outliers. One is called as replace. One is called as retrain. 3 options are there. That we are going to see in the further class. Separately for outliers only, we have to spend almost 1 hour. Because in the real life, 100% we'll get the outliers. and we have to treat. And this is guarantee question in the interview. Guarantee, no doubt in that. For data scientists or machine learning engineers, this question is mandatory. Guarantee they have to ask. How you are going to treat the outliers? You are having three options. Which option you are going to select in which scenario? You are having three different options. Which one you are going to use in which scenario? That is also question. These things, how to treat the outliers, this we'll discuss in the next further, right? First, let us complete the EDA part. Okay, that is analyzing the data. Let us complete that one. After that, analyzing what we have to do. Now, here you have observed. First, this grade column is having the outlier. Right in the notes, grade column has the outliers. This particular column has the outliers. Next, second column has the outliers. Third column, whichever the columns are having the outliers, list all the columns. And similarly, whichever the columns are skewed distribution, all the list of columns. You have to take all the list of columns and keep it separately. Okay, these are the list of columns which are having the skewed distribution. These are the list of columns which are having with respect to outliers. Separate them. And according to that, we are going to do the data cleaning. Okay. So for example, someone has given you some material. Okay, some material they have given to you. Assume. Okay. Forget about the Python, forget about the data science, everything forget. They have given you some material. What is that some material means? Let us take like this, some coins. I have given you some coins. Okay, 1 rupee coins, 2 rupees coins like this, 5 rupees coins, whatever it is. I have given you the coins. Within that coins, some of them are dirty. Some of them are not printed properly. Or some of them are having some kind of some damage. Whichever the coins are damaged and that coins should be modified. Which are the columns, which are the coins are not damaged, we need to modify. Now, what you are going to do? I have given you 100 coins. First, you are going to take coin number 1. First, you will take the coin number 1. First, you will inspect that one, whether this coin is damaged or whether it is having any problem. No, if it is not having problem, you will keep this one side. Okay, one side. Now, you will go to the second coin. Again, you will observe that one. Is there any damage? Now, you will keep this one side, or you will keep side, or directly you will go to the processing unit and you will modify that one. And then again, you will see the third coin. What you will do? You will keep all the coins which are having damage. First, you will keep side, and you will take all the coins at a time for the processing unit. And then you do the modification. You will not do the for single variables. For single coin, you will not do the processing, right? First, I will complete the second coin. Once it is completed, I'll go to the third coin only. Until that, I'll not go to the third coin. We'll not do like this, right? First, we'll identify which are the not proper. First, we'll identify them and we'll separate them. Later, we'll start the processing. Within that processing also, some coins will have with respect to internal damage. Some coins will have with respect to only mud will be there. On the coin, mud only will be there. Means on the overall, wherever the 1 rupee is written, on the 1 rupee only the blackishness will be there. But everything coin will be perfect. For that coin, what we have to do is just we have to clean. But some coins will be damaged. That coins, what we are going to do? Then we are going to restructure that one. The previous one we may delete or we may modify that one. That depends. That depends on the coin. If the coin is having only the edges are not proper, what you are going to do? In some way, some technique we are going to. If the completely coin is damaged, for example, your 10 rupees note is there. If only one part was cut, what you are going to do? You are going to attach the plaster or something in the back end. Some gum or plaster or Fevicol, whatever it is, you are going to attach. One slide cut is there. If complete paper is cut, means what you are going to do? In that case, what you will do? Both the cases are not same, right? Complete paper wastage is different and only slide cut is different. Both are different. Both scenarios are different. How we can apply the same logic on both the scenarios? Based on the damage percentage, we'll do the reaction. Our reaction will be based on the damage percentage. If the damage percentage is very, very, very light, just by writing the Fevicol on it, will be completed. For the 10 rupees note, example. If the damage is more, if that note is not useful and none of them is taking outside, then we'll submit that one in the bank. For a small cut, minute cut, the paper, this much of note, very small, minute cut is there. This one also you are going to take for the bank, sir, this was, there is a cut, sir, please replace this one and please give me 10 rupees new note. Are you going to ask like this? You are not going to do, right? So that in which scenario, which one we have to do miss, that completely depends on the data. Tomorrow in the data science also, we'll get the different types of data. Okay, different types of data, where in that data, slight cleaning is required or heavy cleaning is required. That depends. We can't prefix now itself. We don't know what type of data we are going to have. So after seeing the data only, we can decide that one. So first, before seeing that one, first we are analyzing, okay, which columns are having the outliers. First, we'll separate the list of columns. Which are having the skewed distribution, we'll separate those columns. Wherever the outliers are there, we'll do the outlier statement accordingly. Whichever the columns are skewed, the list of columns which are skewed, each column we are going to convert to normal distribution. Okay. So that is we are going to do in the further. That is called as data cleaning and data transformations. Cleaning the outliers is called as data cleaning. Transforming the variable from skewed distribution to normal distribution is called as data transformations. That we'll see in the further. That is in the mostly once the matplotlib and C1 is completed, next step is data pre-processing. Once the data pre-processing also finish, directly we'll enter into the machine learning. Now the machine learning will apply from the starting to ending whatever we have learned from core Python for data science, descriptive statistics, inference statistics, null and alternate hypothesis, matplotlib, what are the box plot concepts or what are the concepts, Seaborn, data cleaning, data wrangling, whatever the concepts we have discussed from the last 2 months, everything we are going to apply on the machine learning. Machine learning is a combination of all of them, right? So to understand the machine learning, we are completing all the basics which are required, right? Now, so histogram tells us whether the given data is skewed or not. First one, and it is going to identify which is the data is the maximum data lies in which location, right? Similarly, box plot. What is the use of box plot means? Box plot identifies the outliers. At the same time, box plot, one more advantage of box plot is based on the box plot, we are going to identify whether the data is a skewed or normal. Now here, 2 boxes are uneven. Now, whether it is a skewed data or normal data, it is a skewed. Out of the skewed, which one is it is skewed? Right skewed or left skewed? Right skewed. So this is the upper one is right skewed. Lower one is having maximum is left skewed. If you convert this same box like this, you are having like this. This is the maximum area. So it is a right skewed. This we have seen in the descriptive statistics. So that is one more advantage. Using the box plot, we can identify whether the right skewed or left skewed. At the same time, outliers also. But main advantage is outliers. Because here, if it is having a line like this exactly also, we may not say exactly perfectly. Sometimes we may not say that perfectly. Exactly we can't identify. So then that is the reason less priority will be given for the checking the normal distribution. But at the same time, we can do. Similarly here, from the box plot, we can identify the outliers. Is that clear, guys? Next comes to the scatter plot. Now, what is meant by scatter plot? Let us observe. I'm having X and Y. Let us take a small example, X and Y. I'm having this one, 1, 2, 3, 4, 5. This is 6.6. This is 9.4. And this is 1.9. 1.9. This is 4.6. This is 9.1. Something you are having like this. Assume. Okay, some data you are having like this. Now, what is meant by scatter plot? Scatter plot means nothing but first record. This is called as one data point, 1, 6.2. This point you have to take on the x-axis with respect to 1. Y-axis value, wherever the 6.2 is there, you have to keep a dot like this. Okay, and you have to go to the second data point. Second data point 2, 9.4. Let us assume this is the 9.4. 2, 9.4. 3, 1.9. 3, 1.9. 4, 4.6. 4, 4.6. 5, 9.1. 5, 9.1. If you plot like this, each and every data point, this is one point. You are keeping one point on the scatter plot means this point is x, y. Two values should be there. One is corresponding to x value. What is the x value? One is corresponding to your y value. 2 values should be there, x and y. If 2 values are there only, then only you can make one single dot on the plot. If you want to keep one dot means it should have with respect to 2 values. For example, I'm keeping a dot here. Some dot I'm keeping here. What is the meaning of this? It is nothing but 1, 0. 1 is on the x value. X distance is 1. Y distance is 0. That is the meaning of that. Right? Now, what is, if I keep a point here, what is the meaning of that? It is a 0, 0. For any one point, if you want to keep means, we have to require the x and y, 2 values. This is 2 comma 9.4, 3 comma 1.9, 4 comma 4.6, 5 comma 9.1. For each and every data point, if you keep every data point on the plot, then it is called as scatter plot. Okay, whether it is, for example, you are having 6 comma minus 4, 6 comma minus 4. Where is minus 4? This one is the minus 4. This is 1 point. Whether it is a positive or negative, that is secondary. Keeping the dots on the plot is called as scatter plot. Okay. Similarly, now in this particular variable, plt dot scatter. Plt dot scatter means it is going to create a scatter plot. This scatter plot is designed based on the two variables, that is df of grade and df of study variables. Two variables are required. If you give only one variable, it will throw the error because scatter plot is not designed for the single variable. Scatter plot was designed for two variables, which is bivariate analysis. Scatter plot is a bivariate. If you give the two variables along with the grade feature, you want to add the one more feature also. Two features, if you give only, it will work. It is called as bivariate analysis. Scatter plot comes under bivariate. Now, here, whatever the scatter plot we are having, so this is the scatter plot. Just how to draw the scatter plot means plt dot scatter. Nothing else. Now, whenever you have written the plt dot scatter like this, it is going to give the scatter plot. Yeah, three variables are also not possible. If you go with the third variable, again, it is going to throw the error. Right? Exactly two arguments. This particular function was created with two arguments, x and y. Remaining all of them are default arguments. Compulsory arguments are two. This particular function was created with two arguments, two compulsory arguments. Right? Now, if you observe here, by default, it is going to consider the scatter plot where the each plot is circle. Each of them is a circle. Each point is a circle. And that too, the color is blue color. By default, blue color. If you want to change the color to red, color is equal to red. If you write like this, it is going to change to red color. Okay. By default, it is going to take the blue color. Right? So if you want to change the color to the red means you can change the color to the red. And if you want to change the marker means nothing but each dot, whatever you're keeping. You want like this star, something star you want to keep. Marker is equal to, by default, it is going to take the circle. Wo, by default, this is the wo. By default, it is having like this. Now, instead of this one, I want the star mark. So it is going to take the stars. The markers will be considered. Each data point will be marked as like this. Right? If you write the star, instead of star, if you write with respect to plus symbol, whatever you are writing, it is going to consider. Okay, so this is not important for us. This marker is not important, color is not important, nothing is important. Just plt dot scatter means it is going to make between the two plots. Whatever the default color is there, you keep as it is. Now, what is the use of giving this color or something means when you are doing with, for example, two different things, like in that case, we require the colors. What is meant by that? We'll see one by one, right? So here, we are taking the two variables. We are just applying the scatter plot. Now the question is, what is the use of scatter plot? What is the use of scatter plot? What is the use of histogram we have seen? What is the use of box plot we have seen? Now, what is the use of scatter plot? From the scatter plot, we can identify the direction. As x increases, y is increasing or y is decreasing. If your scatter plot is like this, as x increasing, y is decreasing. If your scatter plot is like this, as x increasing, y is also increasing. Is that clear? In this scatter plot, what are the scatter plot you are having? In this scatter plot, as your x value, 1, 2, 3, 4, 5. If you take the points, your y value decreasing, coming down. In this case, as your x values changes, your y is increasing. Okay. So this scatter plot says that as x increases, y increases. As x decreases, y decreases. Sir, the same thing I think in the covariance also we can identify, right? That is mathematical. This is plotting. From the plotting, we can identify this one without writing the covariance. Actually, from the covariance, we have to identify that one. If the covariance is positive, means both are directly proportional to each other. If the covariance value is negative, means both are inversely proportional to each other. That we know. Okay, either by using the covariance or correlation, we can identify that one. Same. That is with respect to the value wise. Without using the value, from plotting also we can identify by using the scatter plot. By writing the scatter plot, we can identify the 10. Okay, what is the trend? The trend is increasing trend or the trend is decreasing? Means in terms of the scatter plot, x value increases, y increases or decreases. So we can get the direction from the scatter plot. We can get the direction, and also along with the direction, we can also get the linearity, means whether they are linear or not. Okay, linearity. Now, what is meant by linearity? Linearity means if you are having your data points like this, they are called as linear. If you are having the data points like this, some curve, the points are making some kind of curve. This is linear, means straight line. The points are making straight line. If the points are making with respect to curve like this, then it is called as non-linear. Anything, any curve, whether it is a quadratic curve, whether it is a cubic curve, whether it is a log curve, whether it is an exponent curve, any curve comes under non-linear curve. Only the straight line, purely straight line comes under linear curve, linear line. Straight line is considered as the linear line. Only the straight line, nothing else. The straight line might be in terms of where we are having the horizontal line or we are having the vertical line. This is also straight lines only. Along with that, slanted line, where there should not be any bend. Without having any bend, then it is called as linear line, right? So from the given data, we can identify whether they are linear or non-linear. Example, let us see like this. So in the next further class, we are going to discuss the machine learning. In the machine learning, let us take like this, one of the example, where I'm going to apply the scatter plot. This is the future data, where we are going to do the entire project. Now here, I have got the scatter plot like this. Now from this scatter plot, this is the scatter plot. Okay, assume this is X and this is Y. Now tell me, as X increases, Y is increasing or decreasing? Increasing. So the relation between X and Y is directly proportional to each other. And from this, can you take a straight line, or the points are like this? It is forming some kind of curve. It is a straight. So since it is a straight, where we are having with the linear, so I'm applying the linear regression concept. If the points are like this, I'm having the points like this. In this case, I'm going to apply the non-linear regression. Based on the points, we are going to identify which type of algorithm we have to identify. That we can decide based on the data. So in that case, scatter plot plays the major important role. Histogram along with the scatter plots. Everything. Okay. Is that clear, guys? So since I have considered very small amount of data, you are able to see like this. Why I have considered small amount of data? Means we can do them manually also. You can take one graph sheet. In the graph sheet also, you can plot everything. You can do this histogram by selecting the graph sheet. You take one graph sheet with you. And you forget about there is no matplotlib. They have given the data set like this for you. For this data set, they ask you to apply the, for grade, draw the histogram manually. How you are going to draw? So first, from where you are going to start? This is the 3. Minimum point is 3. 3 to, you are going to take up to 19.2 as 1. From 19.2, you are going to take plus 16.2. That is nothing but 35.4, up to 35.4. You are going to first keep the points. You will create the first the data points. Once you create the data points like this, the maximum value of up to 165. Once you create that one, now you line 5 from 3 to 19.2. How many values are there? 1, 19.2, 1. Only one data point is there. Okay. So you are going to draw up to a height of 1. And after that, you are going to draw the next one. After that, from here to here, how many data points are there? According to that, you are going to draw. This you can do the manually without using the matplotlib also you can do. If you are considering a small amount of data, if I give 200 records, what happens? It will take so much of time. We can do that one also we can do, but it will take somewhat more time. For 2000 records, more time. For 10,000 records, still more time. Time increases. Everything we can do manually, but time increases. Instead of that much of wasting our time on the manual process, the shortcut is machine. All this machine learning and with respect to whatever the coding part we are doing to reduce the human efforts. Okay. In order to reduce our human efforts, we have created all these things. Right? Is that clear, guys? So just we are analyzing the data, histogram, box plot, and scatter plot. Is that clear? Scatter plot comes under bivariate analysis. Next, here I'm going to take x is equal to study hours, y is equal to grade, scatter between x comma y. What is x variable? What is meant by x? Study hours. What is meant by y? Grade. Automatically, it is going to consider in that way. Color is equal to blue. The whatever the points I am going to keep, each point should be blue point. Color should be blue. Marker is equal to 0. 0 means O. O means this one. Circle. The each data point should be circle. S is equal to 30. 30 means, for example, let us take like this. This is one dot. Here I am increasing my size. This is, see, if I keep a dot also, just I'm keeping one dot like this. For one dot also, this much of big one I'm getting. What is the difference between this one versus what is the difference between this one? Thickness, size, right? The size is this. Yes. Now by using x is equal to 30, you are going to get the size will be more. If you increase the size to 300, right? If you write 3000, right? The circle size, what is the circle size? The circle size is with respect to, we are considering this one, right? So generally, we don't require the circle size, we don't require the marker, we don't require the color. Nothing is required, because whether the color is green color also, answer is same. Whether it is a blue color also, answer is same. Just we are identifying what is the relation between x and y, whether it is a linear relation or non-linear relation, whether it is having with respect to positive direction or negative direction. Means both are opposite to each other or both are directly proportional to each other. Whether it is in a green color also, answer is same. Whether it is in red color also, answer is same. Whether it is in the blue color also, answer is same. So that coloring is not important for us. For whom the coloring is important then? For data analyst, the coloring is important. Why? Because for data analyst, the ultimate goal is itself to make a beautiful plots. The ultimate goal itself, beautiful plots. By showing the beautiful plots, he has to give that one to his client or manager or someone. He has to show with the plots. Okay. We have to show them with respect to the plots. For example, let us take like this. In Naresh IT, sir, how your students are performing? I'm going to take the marks, your marks. Test 1, test 2, test 3, test 4, test 5. Let us assume I have conducted total 5 tests. I'm having the 5 test marks. I'm going to show that, sir, in the first test, test number 1, my students has got average score is this one, some average score. I assume that average score is 54. Test number 2, the average score was raised to 62. Test 3, the average score has dropped to 58. Again, the test score was raised to 70. Again, the last test score was this one. So now this one, the test score is gradually increasing. By conducting the multiple tests, the students are getting aided towards the test and they're taking the test multiple times, and automatically the score also getting increased. This is the data analyst role. If Naresh IT team ask me, sir, can you analyze the data and how the students' performance is, then this is the answer. Now the same Naresh IT, if ask me that, sir, based on the students' data, can you predict what would be the number of students are going to admit in the next batch? Can you predict? Then this concept is not important for me. This is not important for me. Based on the project, which is important, we are going to do. For descriptive analytics project, plotting is more important. For data analyst role, plotting is more important. For data scientist role, prediction is more important. Predictive analytics plays the major role. For data analyst, descriptive analytics plays the major role. Descriptive analytics means analyzing the data and visualizing the data within high level plots. That is the reason in the outside market, someone learns the Power BI. Someone learns with respect to the Tableau. Means they'll become as a data analyst. They can't become the data scientist. They become as only data analyst. Okay. Someone has to become as a data scientist or ML engineer or something related to this. They have to learn the machine learning and artificial intelligence stuff. Because data scientist work is to do the prediction, not to analyze. Okay. Is that clear? Anuradha, just at the end, let us see. Anuradha. Right. Now, coming to the next one is called as line plot. The next type of plot is called as line plot. Histogram, box plot, scatter plot. 3 things are completed. Now, the next plot is called as line plot. Now, what is meant by line plot? Line plot is used for the time series data. As the time increases, how the data increases. Okay. So what you are going to take, you are having two columns. The first column is called as time date, assume date or month or whatever it is. For example, I'm working on the Flipkart sales where I'm having the monthly data and this sales. April month, I'm having in terms of April month of 140, May month 120, June 400, July 480, something I'm having like this. Assume. Now, what you are going to do, this date, whatever the time series is there, time series you are going to consider on the x-axis. That is April, May, June, July. And this one, whatever the values are there, that you are going to consider on the y-axis. And you are going to make a dot. Means what you are going to do? Scatter plot. You are going to apply the scatter plot for 140, 120, 400, 480. Something you are going to make first scatter plot. Now this scatter plot, you have to attach the data points in the sequential order. All the scatter points you have to attach in the sequential order. Then it is called as line plot. You can't attach as per your choice. Means you can't attach first this two, followed by this one, followed by this one. You can't attach like this. Not as per your choice. In the sequential order, you have to attach the, if you are attaching all the scatter points in the sequential order, then it is called as line plot. Okay. Line plot means nothing but attaching the scatter points, whatever the scatter points are there, attaching all the scatter points in the sequential order is called as line plot. Right? So here instead of month, I'm having date. Assume it is having date. Date is 24, 2023, 21, 4, 2023, 22, 4, 2023, 23, 4, 2023. You are having like this. Now the dates will be on the x-axis. 24, 21, 4, 22, 4, 23, 4. Dates will be on the x-axis. Whatever the time series is there, time series should be on the x-axis every time. Now date wise, you are going to make the, for each date, first you have to make the scatter plot, that is dots. Now you have to attach all the dots in the sequential order. That's it. Is that clear? Attaching all the data points in the sequential order is called as line plot. Generally, this particular thing will be applied for the time series data. Now let us take like this. Here I am having the study hours versus grade. Okay. Now what happens? First, it is going to make a scatter plot like this. Now in this scatter plot, from this scatter plot, it is going to take each of them. Okay. Let me take in this way. Let me print the DF here itself. So first data point is 10, 50. Where is 10, 50 in this scatter plot? This is 10 and 50. Where is 50? This is 10 and let us take, this is the 50 value. Okay, 10, 50 means this is the one, first data point. Next, what is the second data point? 11.5, 50. 11.5, 50. This is 11.5, 50. From here to here, first it will attach one line. After that, it will go to the second data, third data point, fourth data point. Like this, it is going to move one by one. And if I apply the line plot, for line plot, what is the function? Means PLT dot plot. PLT dot plot. And now if I observe this one, see, I got in a zigzag way. Because they are not in the sequential order now. So if you go with a normal cross-sectional data, if you apply the line plot, it will give like this. So line plot should be applied not for cross-sectional data. Line plot should be applied for the time series data. Time series data or X, where the X is in the increasing order. Wherever your X is in the increasing or decreasing order. When you are having some sequential data, then you can apply. So let us take like this. Now PLT dot plot, I'm going to take the grade, only the grade column. I'm not going to consider the second column. Now what happens in this case means automatically the x-axis is going to be the index numbers. It is going to consider the index numbers. Now first record index number 0, 1, 2, 3, like this index numbers. As the index numbers continuation increases, so you are having the line plot in a visible way. By default, it will take the x-axis as the index number if you don't write anything. So now the Yeah, guys. Online students, can you hear me? Online students? Yes. Due to some power cut issue, there is a problem in between. Right. So let's start. So in the matplotlib, line plot means where we are having in terms of sequential data. The x-axis, whatever on the x-axis there, the x-axis should be in the sequential data. See, the x-axis value should be in the sequential order. Then only apply the line plot. If the x-axis is not in the sequential order, then automatically you will get a zigzag line plot. In that case, we should not apply this particular line plot. Whenever your x-axis values, whether you are considering time series or whether you are considering index numbers, whatever it is, but x-axis should be in the sequential order, whether it is in the increasing order or decreasing order, always the x-axis should be in the sequential order. If the x-axis in the sequential order, apply the line plot. If the x-axis is not in the sequential order, don't apply the line plot, right? Now here, plt dot plot of df of study hours. What is meant by df of study hours? Miss, it is going to consider only the study hours column. Then automatically x-axis what it is going to have? Index numbers. If you write only one column, if you give only one column, one variable as the input, automatically x will be considered as the index. If you have given two columns, that is x comma y, two columns if you give miss, the x first, whatever the first one you have written, this will be considered on the x-axis position. This will be considered on the y-axis position. Okay, is that clear? So within the plt dot plot, x is equal to default index. The function was created in this way. X is equal to default and y. If you give the x value any number, particular anything, it will take. Otherwise, it will take the index. By default, it will take the index. X is considered as the default argument. So whenever you have written the plt dot plot, x is equal to, instead of index, if you write x is equal to df of study hours and y is equal to df of grade, if you take like this, study hours and grade, then automatically x will be considered study hours, y will be considered as grade. Instead of that, if you write only the plt dot plot of df of study hours, if you take only like this, automatically this will be considered as y and x is equal to index. Sir, clearly if I write here, this is x is equal to, if I write the keyword argument, x is equal to, but I have not given the y, then it is going to throw the error. You have given the x, but you have not given the y, it will throw the error. If you don't write this keyword argument, automatically this argument will be considered as y and x will be considered as the index numbers. In that way, it is going to work. The functions, we already seen the how the functions work with the keyword arguments, default argument, positional arguments, all these things we have completed in the functions concept, right? It is going to work based on that, right? Now, so here I'm going to write df of study hours. Okay, if I write df of study hours, only this one, it is going to take this one as the y variable. On the x-axis, automatically index will be considered. If I write this one, x is equal to, this is equal to x is equal to, it is going to throw the error. Okay, x is equal to, you have given me, then what is y? I don't want x, I want y, the y variable. That is more important for line plot, not the x variable. If you write this one as y, automatically x is index numbers. It is going to take the x is equal to index numbers, right? So this particular, it is going to consider the two arguments. One is x and one is y. Okay. Now, if you write like this, automatically it will take that one. Now, next one we are having is color. Color is equal to, I'm writing as green color. By default, blue. Python by default, it will select the blue color by default. Okay. So here, whatever the tool I'm having, if you observe this particular tool, whatever I'm using the pen tool, this particular pen tool, by default, it will go with the pink color. By default, this is the default color. If I write something miss, you will get in the pink by default. Now, if I want to change miss, I'm going to change the colors. Within this, what are the colors I want, I'm going to select it, right? Now, so here, similarly, by default, it is going to take the blue color. If you want to change the color, you can change the color by writing the green. So you're going to get a green color. If it is green color or if it is a blue color also, for us, both are same, right? And next, line width. Line width is equal to 3. Means thickness. Line thickness is equal to 3. By default, it is going to have the 1. Thickness will be 1. If you increase the thickness to, for example, something like this, more thickness will be there. Thickness of the line increases, right? So for us, this all, nothing is important. Only the plt dot plot sufficient. Now, what is the use of line plot? What is the use of scatter plot? We have seen. Now, what is the use of line plot? A line plot identifies that how the trend is there, whether the trend is increasing or whether the trend is decreasing. That we can use using the line plot. Okay, particularly this line plot, major application of this line plot is in the time series. And in that particular time series, the most important project in the time series is nothing but stock market. Right? In the stock market or share market, we are having with respect to different types of shares. For example, one of them, if you want to see, I'm going to use the, okay, if you select any one of the company name, let us take the company name as Reliance. And now if you see here, this is the line plot. As the date increases, for each day, the Reliance share value, the value they have taken, and for each day, what is the Reliance share price? This is the line plot. As the day changes every day, what is the value? On this particular day, that is 28th, it is with respect to this much of amount. On 27th, on 28th, 29, like this. For each and every day you are having. Sir, here you can see one box is there, right? You are seeing the box. One box with the date and the value and everything, you are seeing one box, right? This is basically designed on the Tableau. This Tableau, in the backend, Tableau is working. Okay, Tableau was integrated for this website. This is the backend is Tableau. Tableau or Power BI, something. One with data visualization tool. So for that data visualization tool, we can get this type of thing. This is called as interactive. The box is called as interactive in that. You'll see that one, right? So this is the line plot. Means when you are going to apply this line plot concept, the entire concept of line plot means for time series data, because as x-axis increases, day increasing every day, you are going to have, right? And from this line plot, what we are going to observe? Okay, I have given this graph. What you are going to observe the line plot? Now, how is the trend? The trend is with respect to either increasing or decreasing. So if you draw a lower values, if you attach all the lower values, the lower values are coming down. Means it is reducing. If you attach all the upper values, wherever the upper values are there, attach all the upper points. If you attach all the upper points also, it is showing that it is decreasing. So the trend is in the downward direction. That we can identify from this. Okay. I can identify overall trend from May 2022 to now, how the trend is there. Means continuation, it is decreasing in the downtrend. So based on this trend, none of the, if whoever knows about the stock market, they are not going to invest on the Reliance. Again, when the trend starts in the increasing direction, something, they'll start investing. When the trend changes to the upward direction, they'll start investing on the Reliance. They'll invest the money on that and they'll purchase the shares. So if the trend is in downwards, they'll not go with the value. Like this, whatever the company, whichever the company you want, you open the company and just they are going to observe the trend. And based on the trend, that is one of the parameter. For stock market, just by using the line plot, don't invest. Okay, stock market is not that much of easy, right? Just by observing the line plot or by using the time series analysis, machine learning or deep learning, we can't invest. So in this, so many things will be there. Intrinsic values will be there. ROC will be there. ROCE will be there. PE will be there. So many of things are there, right? Again, this is a separate chapter. This is related to finance. If you do any particular project on the stock market, in that case, we have to understand all these parameters. Every column, these are all the column names. Everything you have to analyze. So again, you are going to get like this in terms of CMP. CMP means current market price, PE, market capital, all these things. This all of the structured data, you have to take the structured data and you have to start the analysis. For doing the analysis, first you have to understand what is meant by NP, right? What is meant by NP means net profit. NP, net profit. QTR, what is meant by QTR means quarterly wise. And DVI means dividend. What is meant by dividend? Again, full form is dividend. Okay, what is the meaning of dividend? That we have to analyze, understand. Then only we can do the project. Without doing that one, just by taking the data set, load in the Python and apply the machine learning, then you'll not get the proper result. That is not called as proper analysis. First, we have to understand what are the things and which columns are important, which columns are not important. Based on that, we are going to work. All right. Now, so this is the line plot, right? Now, here I'm going to take x is equal to np dot arrange of 6. Np dot arrange of 6 means 0, 1, 2, 3, 4, 5. Y, this is x. Y is equal to x. Y is equal to x means 0, 1, 2, 3, 4, 5. it is going to create one more copy of that one, which is nothing but deep copy. Deep copy means both of them will assign to the same variable. Whenever you have written dot copy, then it is shallow copy. It will create a new object. Otherwise, both of them will refer to the same object. Right. Now, just z is equal to x to the power of 2. X to the power of 2 means for each and every value, it is going to apply the x to the power of 2 because numpy is application of for loop. Okay. So for each and every value, that is 0 square, 1 square, 2 square, 3 square, 4 square, 5 square. This is z. Next, e is equal to x to the power of 3. E is equal to x to the power of 3. Okay. X is equal to 0, 1, 2, 3, 4, 5. Y is equal to 0, 1, 2, 3, 4, 5. Okay. Z is equal to 0, 1, 4, 9, 16, 25. E is equal to 0, 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125. So these are the values. Now I'm having 4 variables are there: x, y, z, e. Now first I'm going to make a plt dot plot on x comma y. First is what is meant by plt dot plot? Plot means line plot. Line plot means first you have to make a scatter plot. Scatter plot between 0, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And you have to attach all the scatter plots in the sequential order. Then it is called as line plot. So this is the line plot which you are going to get. Okay, which passes through the origin. 0 to 0, it will pass us. Right? Next, you are going to make a plot between x comma z. Now x comma z means this is the x value. 0 comma 0 is the first point. 1 comma 1 is the second point. 2 comma 4, 3 comma 9, 4 comma 16, 5 comma 25. You are going to make a plot like this. And this is your second plot. Okay, between x comma z. Now next x comma e, between x comma e. And this is the third one where you are having 0 comma 0, 1 comma 1, 2 comma 8, 3 comma 27, 4 comma 64 and 5 comma 125. You are having like this, right? Now what I'm going to do is everything I'm going to bring into a single plot. plt dot plot of x comma y, plt dot plot of x comma z, plt dot plot of x comma e. I am going to combine the 3 plots in a single plot. This we can do when everything are having the same x value. Everything are having the same x value, then only we can do this one. Okay. Now what we are going to do is just we are comparing. So I'm having 3 plots, 1, 2, 3. X values are same. Y values changes. Out of which this is x comma y, this is x comma z, and this is x comma e. How I know that one it is x comma e or this one like this? So I'm going to write the label plt dot x comma y. Label is equal to x and y. Label is equal to x and z. Label is equal to x and e. Now what happens? It is going to show the one label like this. Okay, blue color line indicates between the x and y. Orange color indicates between x and z. Green color indicates between x and e. The label here, the label I'll understand based on the label. Right? Now what is the application? Let us see one example like this. I'm having the day. On the day 1, this is the maximum temperature, this is the minimum temperature, this is the average temperature on day 1. On day 2, maximum, minimum and average. On day 3, maximum, minimum, average. On day 4, maximum, minimum, average. Something I'm having like this. Okay. I'm going to make a plt dot plot between days comma maximum temperature. What is meant by days? Days comma maximum temperature means for 1, 50. 1 comma 50. 2 comma 51. 3 comma 52. 4 comma 48. 5 comma 47. 6 comma 49. 46. You are going to have something like this. And this is the first scatter plot. This one. This is the first line plot. Now second line plot. Between the day. Same day only, right? Same ones. I'm not going to modify the x-axis. Only the y-axis will be modified. So for 43. I'll take the 43. Earlier I have taken the 50. Now I will keep the 43. Wherever the 43 is there, that I'll keep a point. Now I'm going to make a line plot for each of the day. Similarly, average temperature. Now using this one, what I'm going to get? 3 lines I'm going to get like this. Now I'm going to compare between the each day, how the trend is there, how the minimum value increasing or decreasing, how the average temperature is there. I can analyze at a time 3 variables. Is that clear? So that is the advantage of the line plot and multiple lines. When you want the multiple lines, everything in a single plot, then you have to take all of them in a single cell and you have to execute at a time. If you don't execute like this, if you execute only a separate line, This you have executed separately. This you have executed separately. For example, you are working in the spider, assume. And in the spider, you are executing only this line separately. Then only you can observe only one line. If you execute these 3 lines at a time, if you select the 3 lines and if you click on the enter button, then you can see this plot. So 3 plots will be executed on a single time on a single plot, and you will get a plot like this. Is that clear? Now here in the earlier example that whatever I have shown here, this is for a particular day. Can you see a line plot on the same particular day? Can you see here one blue light color blue bars are there? What is this light blue color bars means? Nothing but volume. Volume is how much number of shares has been traded on that particular day. For the same day, one day, if you consider this one day, this is the maximum number of volume was traded. On the same day, you are having the price. Both of them you are indicating for the same X value. X value is fixed, day is fixed. Y value, one is volume and one is with respect to the market price. So this is with respect to, you can take like this. So now you can make with respect to, if both of them are having the same X value, then only we can apply this logic. If both of them are having the different X values, no need of this logic because you are not able to compare now. Okay. So for example, let us take like this. In this particular day, can you see here? This is the particular day. On this particular day, the volume, what is the volume you can see here? 37842K. Okay. Means very huge amount of volume was done on this particular day. At the same time, on that particular day, suddenly the market has been fall. Means the value has fall. Means many of the investors has sold on that particular day. We are going to analyze in that way. Many of the investors has sold whatever this one is there. They have sold off whatever they are having. They have sold off. So they have felt that the value is going to be dropped and they have sold that one. Right. So here we can observe that one. Okay. This at the same time, if you are having this this one like this, instead of coming down, it is upward. Then what you will understand? Okay. Many of the investors are feeling it is going to increase. And we are going to analyze. Right. So on the same day, we are going to compare between two things along with the volume and the price. Both we are comparing. As the volume is very high, price is decreasing up, price is increasing up. Right? That we are going to compare. Now, with respect to this. So similarly here we are having with respect to 3 lines. These 3 lines you are going to compare. For 3 of them, the X value should be the same. Then only the comparison will be there. If X is different, where is the word of comparison? Comparison means on the same day how the, okay, I can understand here. There is a huge drop in the minimum temperature, but there is nothing much, there is no much drop in the maximum temperature. The maximum temperature drop is nothing, but minimum temperature drop is too much. On that particular day, too much of minimum temperature has dropped. Means morning hours, right? It is sunny, it is normal, but suddenly on that particular day, due to some kind of rain or something, suddenly the temperature was dropped in between. Maximum temperature difference is nothing, but minimum temperature was dropped. Means something was happened on that day. That we are going to analyze what happened and what was done. Right? That is the use of line plot. So line plot tells us the trend. So total 4 plots. One is histogram, box plot, scatter plot, and line plot. Total 4 plots we have discussed. And bar plot and pie plot that we are going to see in the tomorrow's class. Bar chart and pie chart along with the stacked bar chart. All these things we'll see in the tomorrow's class. Right? Once the basic plotting is completed, then we'll move on to the Seaborn.